Okay, welcome back, guys. I'm going to try and keep our work as similar as possible to what we were doing in person while we are e-learning. I'm going to try and be available as much as possible through video conferencing and Google Chat for help with problems. What that means for you guys is you need to be working on the problems on your own, and as you need to, email me to check whether things are right or wrong on homeworks, and have the ability to somehow upload your documents, which I think in most cases, I think a lot of people don't probably have scanners, but you may need to take a picture of your page and then upload it in order to share it. I may also get to the point where we do Zoom meetings where we can share screens independently. So we'll see how all that works itself out. But right now we're going to start chapter 10. We are talking about sequences, arithmetic and geometric sequences, and we're starting really basically with defining them and working with them, and then as the chapter goes along we will be writing equations for them, and we will work with special sequences in order to solve more complex problems. So just some general vocabulary. A sequence is a set of numbers that make a pattern. They have to have a pattern. It's not going to be a random set of numbers. There are two ways to describe. It could be finite or infinite. Finite has a limited number of terms. So they may describe a sequence and say, complete the sequence with 10 terms. So you would have a finite sequence with 10 terms, and they may ask you to finish it so that it does have 10 terms instead of like the beginning 4. Infinite would mean that you write the sequence and then you have to create, oops, that's not what I meant. You have to use the ellipse right here. That is called, hang on. Oh, text. That's called an ellipse. Here we go. So an ellipse means that it goes on forever. So we use those dots, and if you see them, it means it goes on forever. If they ask you to write the sequence, and it's an infinite sequence, you have to write those 3 dots to show that. Okay, we can talk about domain and range. The domain of a sequence is the natural numbers. If you remember what that means, that is the counting numbers, natural numbers, and it's the position of terms. So these are, if I can get this on here, these are the counting numbers, and your domain would look like 1, 2, 3, 4, and so on, especially if it's an infinite series sequence, excuse me. The range is going to be the numbers that are in the sequence, and depending on what those numbers are, it's going to just be your terms. So like, for example, here, this sequence 3, 8, 13, 18, 23, so let's pretend that's a finite sequence. Your range would be 3, 8, 13, 18, 23. We're not going to get too much into that until we actually start writing the functions for a sequence. So we just want to talk about it today. An arithmetic sequence, arithmetic, means that it has a common difference. And we will shorten this, so let's do text. A common difference, we'll shorten this as CD, and the CD will be, let's see, for example, for this one, let's see if I can make this happen, plus, this would be plus 5. To go from 3 to 8, we would add 5. To go from 8 to 13, we are adding 5. To go from 13 to 18, we're adding 5. to go from 18 to 23, we're adding 5, and so on, and it's going to continue. So your CD, your common difference, is the number added or subtracted, and that's going to have to come back here. Okay. Let's see if I can fix that a little bit. But it's the number we're adding or subtracting. Arithmetic means add or subtract. The geometric sequence, I'll see if I can fix that later on, but geometric sequence means there's a ratio. So we're going to take the sequence, create ratios, and in order for it to be a geometric sequence, those ratios have to be the same. So if we look here, ratio is same for entire sequence. Yeah, sequence. Okay, so if we look at the current list given here, 2 and 4. See, I want to move this. Okay, I can't. That's okay. If we look 2 to 4, then what we'll do is we will take 4 over 2 and get that this is 2. And we'll take 8 over 4, and that is simplified to 2. And so on. Let me put an ellipse here. And so on. And we'll practice that here later on. But because it's common between these two and all of these terms to get from one to the other, it's a geometric sequence. Alright, so here are the types of problems you're going to be asked to solve. Determine whether each sequence is arithmetic. Arithmetic meaning has to be adding and subtracting. So our instructions over here, number 1, we will check the pattern for all the terms. All the terms in the sequence. Has to be all the terms. And kind of a subset, let's say A, in order for them to be arithmetic, these can only be adding or subtracting. If they're the same for every piece, then we say it's arithmetic. Sequence. What did I spell wrong? Sequence. There we go. So what we're going to do, we're going to come over here and we're going to use my pencil, and hopefully it's not too ugly, but I look between 8 and -2. So I say, okay, how do I go from 8 to -2? And what you can always do is say, I'm going to take the second term and subtract the first. So -2 minus 8. Hang on, let me do this the other way. Let me do it with text and maybe it'll be easier to read. So -2 minus 8 equals -10. Then we do -12 minus a -2. What is that? Minus a negative means plus, so this is also -10. We do -22 minus -12. That equals -10. So, usually how we show it is we show what is the difference between these. So we would draw, this is the math that we do, but we draw little arrows here and we say, okay, how do I get from one to the other? It's -10, -10, and -10. Okay, so because it's the same, we say yes, and we say that up here, arithmetic sequence, common difference. The common difference is -10. That's your answer. Common difference is -10. Okay, so that's a yes. Then we come over here and we look at these. So we will say -5 minus 14 equals, what is that, -19? And -19 minus -5 equals, -19 plus 5 is -14. So were the differences the same? No, they were not. So we say no, there is no common difference. That would be your answer. Okay. For each of these kinds, the arithmetic and geometric, they're going to ask you to find the next so many terms. A lot of the times it's 4, sometimes it's 3, sometimes it's 6. It just depends, so pay attention to what they're asking you for. But your steps here are find the common difference, because here they're telling you find the next 4 terms of the arithmetic sequence. They're telling you it's arithmetic. There is a common difference. So first you're going to find it, and then use the common difference to finish the pattern. Okay, so if we look over here, look at just the first terms, -1 minus -4 equals -1 plus 4, so that's 3. Let's just do one more. Technically you can do all 3. If they're telling you if it's arithmetic, you should be able to just do 1, but let's double check. So 2 minus -1 equals 2 plus 1, which is 3. So yes, they're coming up with the same common difference of 3. So then you just have to continue the pattern. So this one's really easy. So we start off with 5. That's our previous term, and we need 4 more terms. So we're going to take 5 plus 3, plus 3, that's 8, and then we're going to add 3 again and get 11, and then we're going to add 3 again and get 14, and then we're going to add 3 again and get 17. So our sequence is actually, we left off at 5, we got 8, 11, 14, and 17. That is the next 4 terms. That's kind of your answer. Let me see if I can circle that without making this too much trouble. That's your solution there. Okay, I like that. Let's go back up here and give our answers in a circle. Okay, so then we'll look at the next one while I fix this here. There's my answer, and there's my answer. Okay, close enough. Find the next 4 terms of this sequence. So we have to find the common difference. So if I look here, I have 1/5 and I'm going to 4/5. So what do I add to 1/5 to get to 4/5? If you're not sure, then let's write it down. Let's take text. Let's take 4/5 minus 1/5. That is equal to 3/5. If I do the same thing with 7/5 and 4/5, 7 minus 4 is 3/5. So that's my common difference. So then I have to do the work. I'm leaving off at 7/5. 7/5 plus 3/5 will be 10/5. You could write that as 2, but since everything is in fifths, we're just going to leave it like that. We have to take our new number and add our common difference. That will give us 13/5. Add our common difference of 3/5, and that will give us 17/5. And let's check this out. We left off here. We have 1, 2, 3. I've got to go one more. Plus 3/5 will be, what did I do wrong there? Ah, that's 16. See, you guys aren't here to catch me, so I got to catch my own. 19/5. Okay, so then we can take this and write our answers. So we have 10/5. If you write 2, it's correct. I'm not going to count it off, but I'm just going to make everything as fractions. So 10/5, 13/5, 16/5, and 19/5. That's my answer. Oh, it didn't keep it down here like I wanted it to. Alright, well, we'll circle it anyway. That right there is my answer. And I didn't like that. No! Okay, hold on. Bear with me here. Copy. New text box, please. Bear with me. I will get better at this as time goes on. There we go. Alright, and we'll circle this. This is my solution. Okay, determine whether each is geometric. Now we're going to do the same thing for geometric. And geometric was, geometric was a ratio. So we're going to do the same process, but we're not looking for adding and subtracting. Now we're looking for our ratio. So our steps here are, number 1, check check for pattern to make the common ratio, which we will shorten as CR. Okay, so we're going to find it. We have to test all of the combinations. So note here, the ratio must be the same for the entire sequence. And to take the ratio, always take the second term over the first term to make the ratio. That way you always get the number that is multiplied. How do you multiply the first one to get the second? You always, in order to get that correct term every time, we'll take the second over the first. So here's what we're going to do. And these are going to have to be handwritten, so excuse me for this. But we're going to take 21 over 14 and decide what that is. So that is, let's see, they're both divisible by 7, so we get 3 over 2. And thankfully there's only one more. We will take 7 over 14. What does that reduce to? 1 over 2. So we look here, we get the ratio of 3 halves and 1 halves. We have checked the entire sequence. It has to be the same for the entire sequence, so the answer for this one is no, there is no common ratio. One was 3 halves and one is 1 half. So there's not the same. So let's come over here and test the other one. 18 over, second term, 18 over negative 27. So reduce that. They're both reducible by 9. 18 divided by 9 is 2. And it was negative 27, so negative 27 divided by 9 is 3. So hopefully this other one is 2/3, negative 2/3. We'll get negative 12 over 18. These are divisible by 6, so we get negative 2 over 18 divided by 6 is 3. So here they were both negative 2/3. So what you're going to want to say is, yes, it is geometric, and the common ratio is negative 2 over 3. So those were my answers here. Okay, let me circle those. No common ratio, and this one, we got a common ratio of negative 2/3. Okay. Find the next 3 terms in the geometric sequence here. So we're going to do the same kind of thing that we did for arithmetic. We have to investigate the sequence, and hold on, let me flip over my notes. So investigate the sequence and find the next 3 terms. So now we only have to find 3. Geometric, I'm going to tell you these are geometric. Sometimes we don't know, so we have to investigate both. But these are geometric, so we're going to start by checking out these ratios. So we're going to have 48 over 60, oh gosh, sorry, over 64. Those are both divisible by 8. So we'll get 6 over 8. Okay, we had to go farther, so that is 3 over 4. Okay, 3/4. So then we have to check the next one. 36 over 48 equals, now we're divisible by 12, clearly here, so we can do 36 divided by 12 is 3, 48 divided by 12 is 4. They match. So our common ratio here is 3/4. So that's super ugly. So I'm going to use text, but my fractions aren't going to look perfect. So what we have to do is we start with the last term, and with your common ratio, you're multiplying by this common ratio. So it's going to be 36 times 3/4. That is equal to 27. Then I'm going to take that number, and I've got to come up with 3 terms. So I have 27, that's 1. Times 3/4, that gives me 20.25, or you can keep it in fractions if you'd like, but I'm just going to leave a decimal right now. 1, 2, I need one more term, so we multiply by the common ratio again and get 15.1875. So one last thing you have to do is name your points, your terms, I mean. So you'll say 27, 20.25, and 15.1875. These are your next three terms. So you have to investigate, find the ratio, and then use it. Okay, so coming over here, I'm going to kind of use this space to the side. So 108, actually, let me do this. 108 over 81, that reduces to interesting. I kind of cheated on my calculator when I did this. So let's say 9s. So 108 divided by 9 is 12 over 9, which reduces again by 3s to 4 over 3. Okay, so now I can make this look nice. So 108 over 81, 12 over 9. Oh my gosh, guys. Maybe not. Apparently I can't write over that. Great. Okay, well I'm going to leave it like that. Text. Okay. So we get 4/3 for that one. And then we get 144 over 108. So if we reduce that, we can divide by 12, and so this is 12 over, over 9, which will again reduce to 4 over 3. So common ratio again, this is 4/3. Alright. So we're going to take the sequence and we're going to multiply. My last term was 144. And I have to multiply that by 4/3. That is 192. And I need 3 terms, so I have 1, I need 2 more. Multiply by 4/3. That is 256. Multiply by 4/3. That is 341. And 1/3. So my final piece, my answers will be 192, 256, and 341 and 1/3. Okay, hopefully those are all very straightforward. This section should be quite simple for you guys. Basically, it's find your common ratio and multiply. Last thing is decide if these are arithmetic, geometric, or neither. So basically, they cannot be both. So a sequence can't be arithmetic and geometric. It will be one or the other or neither one. So we have to test for addition or subtraction pattern. If there's not a pattern there, then we have to test again for a multiplication or division pattern, and if there's nothing there, then we say neither. As soon as you find a pattern, you stop. So say, as soon as pattern is found, stop. If no pattern, say neither. Okay, so we check out the addition and subtraction. So if I check this one, how do I go from 3 to 12? Well, I add 9. How do I go from 12 to 27? 27 minus 12 would be 15. And 27 to 48 would be 21. So not arithmetic. Okay, then we have to test our ratios. So we're going to put 12 over 3. Okay, Okay, well that is equal to 4. Alright, then if we do, hold on, there we go. Then if we do new text box, I'll just work down this way. If I do, what? Sorry, technology is wonderful. Alright, 27. Yeah, let's just do it that way because I think it's going to be easier to see. Delete. Okay, so if I do 12 over 3, that is clearly 4. Then if I do 27 over 12, that reduces by a factor of 3, so it's 9 over 4. And 48 over 27 reduces by a factor of 3, which is 16 over 9. So these do not match. So not geometric. So we say neither. And it really didn't like that. Okay, well it's neither. So that is your answer. This one's a little more complex. If you can see a pattern right off the bat, go for it. So I can see by this one, we have fractions. What do we notice? They're all negative. So if it's addition or subtraction, we would be seeing changes in the top. It has to be a multiplication and division if it's anything. So we're going to test ratios. You can prove to yourself, let's see, if I did, and I did it when I did the problem, but basically you can check, say negative 2 over 25 minus negative 2 fifths. When you put that together, we get 8 25ths. Because we get negative of a larger number, so it goes up. Then I tested negative 2 over 125 minus negative 2 over 25. That was our second term. And we got here 8 over 125. So it's not arithmetic. But you probably could guess that just by looking at what's happening in the problem. So we test geometric. We're going to take negative 2 over 25 and we're going to divide it by, I'm just going to say divided by negative 2 fifths. That way it's clear what's happening. When we do that, we get 1 fifth. Then we take negative 2 divided by, negative 2 over 125 divided by negative 2 25ths. That also is 1 fifth. And remember, you have to check all of them, so make sure one more time. Negative 2 divided by 625 divided by negative 2 over 125, also 1 fifth. So we have a common, so the common ratio is 1 fifth. So we can keep going and we can use our math. So we have to find, no wait. We don't have to find the next terms, I'm sorry. We're deciding whether it is arithmetic, geometric, or neither. So we would say here it is, this sequence is geometric, and the common ratio is 1 fifth. In your homework, it will say determine whether something is arithmetic or geometric or neither. I need you to say whether it's arithmetic or geometric, and if it is, name that common ratio or common difference. So you must have both pieces. So a couple of notes as you go through your homework problems, which you're going to do tonight. If you are asked to graph a sequence, it goes on a coordinate plane, so an XY plane, as individual points, not a line. It is not a solid line. It is individual XY points. And the X is, when you do this, remember your domain is 1, 2, 3, 4, 5, etc. It's just the number of the terms. So the first term goes on x equals 1, second term on x equals 2. Your range, or your y's, is the value of the sequence. Okay, and just as a reminder, always name the common ratio or common difference. Okay, we are doing the problems that are from the problem set that I sent home with you. That is your homework for tonight, today. Work on it. Send me emails today. I will probably, as soon as I get my Google Classroom up, I will hang out on Google Hangouts and you can ask questions there. I will also send out some information once I have that going, but I'm having some technology issues that the IT people have to fix. So as soon as I get that fixed, I will send out more information, but you can use this video. You can do the problems from tonight. You'll find them fairly easy, I think, except maybe the graphing, but I think you can figure that out. So good luck, and email me with any questions.